Hello, in this video, we will learn about matrix factorization, more specific LU factorization and LU decomposition. So yeah, it's all about matrix factorization. And what is matrix factorization? Matrix factorization, also known as LU factorization or LU decomposition, is basically a factorization of matrix A. Here, let me go scroll down. So matrix factorization is a factorization of matrix A, an equation that expresses A as a product of two or more matrices. It's basically breaking it down into more than one matrices, if that makes sense. Matrix multiplication is a synthesis of data. Matrix factorization is an analyst of data. So yeah, that's matrix multiplication is a synthesis of data, and matrix factorization is an analyst of data. So this is why we would use matrix factorization, because you can apply um, we can use this we can whoops so yeah, you can apply matrix factorization in computer science and pre-processing used in such programs such as Maple, MATLAB, and Mathematica. I have personally used MATLAB before, so that is why we can use matrix factorization. A way to accelerate the convergence of a linear system, often called preconditioning. Constructing an electrical network with, hold on, let me just scroll down. So, yeah, we can also use it as constructing an electrical network with uh, specific properties. And then the fourth reason is constructing, here, let me scroll down. Yeah, so the fourth reason is construction and determining the amount of sag/stretch on the middle of a bridge or structure. Okay, so those are some of the reasons why we should use matrix applicate factorization. So let's talk about LU factorization. So what is LU factorization? It's based on the factoring the coefficient matrix into a product of a lower and upper triangular matrix. L is an m by n lower triangular matrix, and U is an m by n echelon form upper triangle matrix. Okay, so what does that mean? Let's scroll down. So this is an example of an LU factorization. You're just breaking it. Here's matrix A, and then here's matrix L. You're breaking it down, and then as you can see, uh, over here, you have zeros, right? You have a triangular, and these are all zeros. The star represents numbers, and the U matrix is when the lower part has zeros and the upper has numbers. We've done this before, or we have done this before. So let's go over the steps how to do LU factorization. So step one, find U, this matrix right here, by performing REF, but without row interchanging, so you can't switch rows. Step two, find L, which is that matrix above here, is by using REF commands to find U. And you'll see what I mean by commands. It's like basically row of operations. You've done row of operations before. That's what commands is. And then L can be used. So here, yeah, L can be used by finding the reverse. L can also be used by finding the reversing the order of a step up of operation. I will explain that. You'll see what I mean. Inverse of the elementary matrix corresponds to each REF command for finding U. Example 1 says determine the LU decomposition. Okay, determine the LU. Let's do it again. So what you want to do is you want to get, you see this 2, -4, and this 1? You want that to get zeros, right? You want that lower triangular, you want to do REF and you want the lower triangle to be zeros. So yeah, let me write that down. 1, 2, -4, and 1 to be 0, or lower triangle to be 0, using row of operation, or in our case, commands. So what do you want to do first? Let's make that 2, 0. So what I'm going to do is, you could do it all at once, or you could do it one by one. So let me put this, here's your original matrix. So let me put the commands here. I'm trying to stay neat. Let's try to keep the commands here, or also known as the row of operations, commands, plural. So the first command, or the first row of operation, is I'm going to multiply the -2 row 1 by 3 row 2, and that will give you row 2. So you could do it all at once, or you could do it one by one. It doesn't really matter, as long as whatever, that doesn't make you less confused. Some people could do it all at once. So we're messing with row 2 first, and we have to multiply -2 by row 1 by, and then plus 3 row 2. So what would that be? So it's -2 times row 1. So the first number in row 1 is 3, plus 3 times row 2. So first number in row 2 is 2. Okay, so let me get a calculator. I got it. So -2 times 3 is 6, plus 3 times 2 is 0. So I'm just going to do this one first. I don't want to of it. And then on the other examples, I'm going to go kind of quicker. And then the next number in row 2 is here. So the first row stays the same, 3, 6, -9. But the second row changes. So the first number in row 2 is now going to be 0. Now continue the process. -2 second number in row 1 is 6. And then second number in row 2 is 5. What does that give you? That would give you 3. Okay, continue. -2. Third number in row 1 is -9. Plus last number in row 2 is -3. So remember, if you recall, you always start with the previous matrix. So this is our previous matrix. And that will give us +9, right? -2 times -9 is +18. 3 times -9 is -9. 18 minus 9 is 9. Okay, and then row 3 stays the same. If you want to do it one at a time. Okay, so we got that. Now what next is I'm going to do the second command. I'm going to do is I'm going to mess with row 3, and I'm going to multiply 4 times row 1 plus 3 row 3 gives you row 3. Okay, so you always start with your previous matrix. So now we're starting with this matrix, and we're going to get, let me put it here. So we're messing with row 3, so we're going to mess with row 3 only. And then it's 4 times row 1 plus 3 row 3. Okay, so let's do that. Let's put the work here. So 4 times the first number in row 1, so this is your previous matrix. Row 1 is 3 plus 3, and then first number in row 3 of this matrix is 27. What does that give you? 93. Hold on, did I do this right? It's 4 times row 1, 4 times row 1 plus 3 times row 3. Oh, duh. Yeah, so it would be, so 4 times row 1 is 12 plus 3 times row 3. So first number in row 3 is 0. So that's going to be 12, right? And then keep on going. 4 times row 1, second number in row 1 is 6, plus 3 times second number in row 3 is 27. No 5. Yeah, this would be 105. And then 4 times row 1, 3 times row 3 is -6. Ooh, this is a big mess. It's not. Yeah, so, and then this is 0, 3, 9, and then 3, 6, -9. I kind of did this already, so I know it's right. So the third command is you're going to multiply -9 of row 2 plus row 3. I only did this step by step. You could do it all at once, or you can use a calculator. It's perfectly fine. But I just wanted to show you the steps. So the third command is still messing with row 3, and you're going to multiply -9 by row 2 plus row 3. It gives you row 3. And when you do that, this is what you're going to get. You're going to get this final matrix. You could put this in the calculator, or you could do it by hand. But the point is, you want this lower triangle to be zeros, right? You want this to be 0, 0, 0, and then the rest are numbers. And then you want to be very careful with your commands, right? You want to make sure you write down your commands or your row of operation, because we're going to use these commands later on. So just note, some textbooks or professor wants your pivots once your pivots, but you don't have to, right? Okay. So now what we do is once we have our command and once we have our lower these to be zeros and the rest are numbers, what you could do is find L. So this is why we wrote the command. So L equals E inverse 1 and E2 inverse and then oops, E3 inverse. So what do these numbers do? What does that E1 inverse mean? Well, E1 is basically command 1. And then you take the inverse using a calculator, right? Or by hand, if you have time. So this is command 1. E2 is command 2. And then you just take the inverse. E3 is command 3. And then you take the inverse. Okay? So L equals E1 inverse, E2 inverse, E3 inverse. And so what you want to do is okay, so you want to start with put it in this form. So E1 is you're gonna put it I think I forgot what this form is called. But you put it in this form 10001 0. I think it's like row echelon form. I see how you have the diagonals to be 1 and the rest is zeros. And then what you're going to do is use the command to change it, right? Okay, so remember what was command 1. So if you recall, command 1 was -2 times row 1 plus 3 times row 2 gives us your new row 2. So what that means is you're going to this is out E1, and you're going to mess with row 2, and you're going to do -2 times row 2, row 1 plus 3 row 2, and that gives us your new row 2. So this will change. And then command 2 was 4 times row 1 plus 3 times row 3 gives us your new row 3. So this is you're going to mess with row 3 for the second command. And then the third command was -9 times row 2 plus row 3. So here you're going to mess with row 3. Okay, let me work that out. These are all the commands or the row of operation we've done. Okay, so let's start with command 1. -2 times row 1 plus 3 times row 2 gives us your new row 2. So it would affect this, and you're going to mess with row 2. So when you do that command, it's going to change this entire row 3. I mean, it's going to mess with the entire row 2, right? Sorry. So this is going to be, when you do that, I'm just going to do the work, -2 times 3 times 0, and then the rest stays the same. 1, 0, 0, 0, 0, 1 stays the same, right? Okay. And then let's look at this other matrix. So that's messing with command 2. So it says 4 times row 1 plus 3 times row 3 gives us new row 3. So what that means is you're only messing with row 3, and you're going to multiply 4 times row 1 plus 3 times row 3. And when you do the work, it should give you your new row 3 should be 4, 0, 3, and the 0, 1, 0 stays the same, and then the 1, 0, 0 stays the same. Okay. Now command 3 is matrix 3, and we're going to mess with row 3. And how we're going to do it is we're going to multiply negative times -9 row 2 plus row 3 gives us your new row 3. So when you do that, actually your new row 3 is going to be 0, -9, +1, and the rest stays the same. Okay. Then you take the inverse of each matrix and you can use a calculator. Wow, that is really a lot of work. So I'm not going to do it by hand. You can just put it in a calculator. Okay, so when you do this, when you take the inverse of this matrix, either using row echelon form or whatever form, you should get 1, 0, 0, 2/3, 1/3, 0. And then you're somehow going to multiply all these three matrices and then take the inverse of this matrix and you get 1, 0, 0, 0, 1, 0, -4/3, 0, 1/3. So this is E1 inverse, this is E2 inverse, and then this is going to be, so if you find the inverse of this, you're going to get 1, 0, 0, 0, 1, 0, 0, 9, 1, and that's going to give you E3 inverse, okay? Okay. So wait, what did that? That gave us L, right? That gave us L. So when you multiply all three matrices, you get L. So with a calculator, if you can have the patience by hand, go ahead. You should get this. L equals 1, 2/3. Okay. And then you can also check your work. So how do you check your work? Oops, you can check your work by multiplying A equals LU. So your A was 3, 2, -4, 6, 5, 1, -9, -3, 10. And then it's going to be your L times your U. So your L is this 1, 0, 0. And then your U was 3, 6, -9, 0, 3, 9, 0, 0, -87. Okay, so when you multiply these two matrices, you're going to get this. So that's how you know you did it correct. And yes, it checks out. Okay, let's do another example. So example 2 says, determine the LU decomposition of matrix A, which is 2, -3, 4, 6, -8, 9, 2, 0, 2. So determine the LU decomposition. Basically what they're asking is find L by finding E1 inverse times E2 inverse times E3 inverse, right? So step 1, get U. Get U. So if A equals 2, 3, 4, 6, -8, 2, 0, 2. And what's, because you want to get, what do you want? You want to get this zero, these zeros, and these zeros, right? And then I think what we have to also do is make the diagonals 1. So you want to get this 1, this -8 into a 1, and then this 2 into 1. I think that'll be a lot easier. So let's do the commands. So command 1. So keep control of your command. If I want to make the 2 into a 1, maybe I should multiply the 1/2 row 1 by row 1. And if you do that, this is what you're going to get. You're going to get 1, 3, 1, -3, -8, 0, 4, 9, 2. Okay. And then my next command would be, well, let's mess with row 2. So it's going to be 3 times row 1 plus 1 row 2 gives us your new row 2. And when you do that, you get okay, so what I'm going to do is because you can use a computer and calculator, I'm just going to write out all the commands. I've already done this problem before, so I know it's correct. So command 1, 1/2 row 1 gives us your new row 1. Command 2, 3 times row 1 plus row 2 gives us row 2. Command 3, -4 row 1 plus row 3 gives us your new row 3. Command 4, 3 times row 2 plus row 3 gives us row 3. Command 5, 1/7 row 3 gives us row 3. Okay, so there should be a total of 5 commands that'll give us your diagonals 1 and the lower triangle to be zeros. So when you do all the work, you should get this. Your new matrix should be 1, 3, 1, 0, 1, 3, 0, 0, 1. Okay, see how these are all diagonals and the rest lower triangle is zeros? Good. That is your U. So your U is this. Okay. Now, step two, once you find your U, do step two, find L by reversing the transform. So we're going to do something different now. Because it says determine the LU decomposition. All right. The other one, yeah. So step two is this. It's a little bit different from what we're used to. Okay. So here's our identity matrix. It's a 3 by 3, so it's 1, 0, 0, 1, 0. What we're going to do is write out our command, and then you're going to like literally do the reverse, if that makes sense. Here. So let me write out our commands. So the first command was 1/2 row 1 gives us row 1. The second command was 3 row 1 plus row 2 gives us row 2. The third command is -4 row 1 plus row 3 gives us row 3. The fourth command is 3 row 2 plus row 3 gives us row 3. And keep on going. There was like 7, right? Fifth command was 3 row 2. Or no, there were 5 commands. The fifth one was 1/7 row 3 gives us new row 3. 1, 2, 3. Okay. What you're going to do is starting with the last command, 5, 1/7 row 3 of row 3. That is going to, since you just take the reciprocal of 1/7, so that is going to be 7. What's the reciprocal of 1/7? 7. Row 3 gives us row 3, right? And then look at the fourth command. So you don't have fractions. So if you don't have a fraction, you just take the reciprocal. So not the reciprocal, the positive or the negative. So we have a positive 3. So now that is going to be -3 row 2. And then I guess this 1 row 3 stays the same. And that gives us new row 3, right? Okay, the third command, instead of -4 row 1, it's going to be +4 row 1, and then 1 row 3 stay the same. And that gives us row 3. And then the second command, +3 row 1 plus row 2, instead of +3, you're going to use -3 row 1 plus row 2 gives us row 2. And then finally, the first command is it's a fraction, so take the reciprocal of that. What's the reciprocal of 1/2? 2. Row 1 gives us row 1. Why did I say row 2? This should be row 1. Okay. So what you're going to do next is so you're going to start with your identity matrix and start with 7 row 3 row 3. Then move down -3 row 2 plus row 3 gives you row 3. 4 row 1 plus row 3 gives us row 3. -3 row 1 plus row 2 gives us row 2. Last one, 2 row 1 gives us new row 1. Okay. Start with your identity matrix, which is 1 0 0 0 1 0 0 0 1, and start with our first one was 7 row 3 gives us row 3. So you're going to mess with row 3, and that will give you 0 -3 7 0 1 0 1 0 0. And the next one is -3 row 2 plus row 3 gives us new row 3. So it looks like you're still going to mess with row 3. And that is going to give us, when you do the algebra, that should give you 4 -3 7 0 1 0 1 0 0. Okay. The next order of operation was 4 row 1 plus row 3 gives us new row 3. So you're still messing with row 3, and you always start with the previous matrix, right? So when you do that, that gives us same. It should give you 4 -3 7 You get 4 -3 7 0 1 0. Okay, so the next new matrix should be 1 0. This should be 1 0 0 -3 1 0. And then the next matrix will give you 2 0 0 -3 1 0 4 -3 7. And when you do all the 1 2 3 4 5, all the 5 commands, you should get this 2 0 0 -3 1 0 4 -3 7. Okay, and that is your L. Okay, let's do the same I think this is the same problem. Determine the LU decomposition, but this time is I want you to do we're going to do both methods. I've taught you two methods where you made the where you didn't make the diagonals ones, and then the other method was when you made the diagonals one and then you took like the inverse, right? So here's matrix A, which is the same matrix, 2 -3 4 6 -8 9 2 0 0 2 0 2. And what we're going to do is solve using method one, which is where you find your U and don't worry about making the diagonals one. And then you find L, you take your commands, and then you find L by taking E1 inverse times E2 inverse, E3 inverse. And then you check it by doing A equals LU. And then method two is probably the quicker and easier method. So first you find U, get the diagonals ones, and then step two is you take the reverse command, what we just did, and then A equals LU. So let's start with method one. Okay, so method one. So step one, get all the zeros in the right place. Right. You had 2, -3, 4, 6, -8, 9, 2, 0, 2. And this is going to give you, so when you first do the first row of operation, you get, here, let me write out the command. So I already done this. You could use a computer if you want, or you could do it one by one. It's up to you. So command, I'm going to put it here. So the first one was 3 row 1 plus 2 row 2 gives us your new row 2. Okay, I think that's going to give you 2, 6, 2, 0, 2, 6, 0, -3, -2, right? Okay. The second command was -2 row 1 plus row 3 gives us new row 3. And then when you do that, I believe that's going to give us this matrix 2, 6, 2, 0, 2, 6, 0, 0, 14. And then the third command was 3 row 2 plus 2 row 3 gives us new row 3. And that, I believe that is your final U. And that gives us 2, 6, 2, 0, 2, 6, 0, 0, 14. Okay. So keeping track of your commands. Now what we're going to do is find L. We have 3 commands, right? Okay, so L is going to be E1 inverse times E2 inverse times E3 inverse. So do your identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Your second is same. Okay. So what you want to do is start command one was 3 times row 1 plus 2 row 2 gives us row 2. So you start with the first matrix, right? And Yeah, so it's going to be L equals, and then you just multiply, what do we do? We multiply 3 row 1 plus 2 row 2 gives you your new row 2. So yeah, that's going to mess with row 2. So it's going to be 1, 0, 0, 3, 2, 0, 0, 0, 1. And then the second command was -2 row 1 plus row 3 gives us row 3. So look at the second matrix. It's going to be, you're going to mess with the second matrix and you're going to mess with row 3 by doing -2 row 1 plus row 3. And that will give us -2, 0, 1, 0, 1, 0, 1, 0, 0. And then the third matrix, we're going to mess with row 3, and you're going to do 3 row 2 plus 2 row 3, which will give you your new row 3. So matrix 3 and mess with row 3 only. So that gives us 0, 3, 2, 0, 1, 0, 1, 0, 0. Okay. When you multiply all three matrices together, you're going to get L equals 1, 0, 0, -3/2, 1/2, 0, 2, -3/2, and 1/2. Right, step 3 is you're going to check A equals LU. Okay, so A was 2, -3, 4, 6, -8, 9, 2, 0, 2 equals L times U. Our L was it's what we just found. So that's 1, 0, 0, -3/2, 1/2, 0, 2, -3/2, 1/2. And then your U was 2, 6, 2, 0, 2, 6, 0, 0, 14. Okay, so that was method 1. Now let's move on to method 2. And it's probably the quicker and easier way. So method 2 is uh, let's write out our command. So method 2, our A was this 2, -3. So what we're going to do is make the diagonals, make the lower triangle zeros, and then we got to make the diagonals ones, right? We got to do some row of operation or commands. And it looks like we're probably going to do more than one command. I mean, more commands because we have to get the diagonal zeros. So here's matrix A. And let me write out the command on the lower left hand. So first step is 1/2 times row 1 will give us your new row 1. And that will give us this matrix 1, 3, 1, -3, -8, 0, 1, 9, 2. And then the second row of operation would be 3 row 1 plus row 2 gives us your new row 2. And that will give us this matrix 1, 3, 1, 0, 1, 3, 1, 9, 2. Okay, and then the next one is -4 row 1 plus 1 row 3 gives us your new row 3. And that's going to give us this matrix 1, 3, 1, 0, 1, 3, 0, -3, -2. Okay, and then the third one would be 3 row 2 plus row 3 gives us row 3. And that's going to give you this matrix 1, 3, 1, 0, 1, 3, 0, 0, 7. Finally, the last one would be 1 7th row 3, and then that'll give us your new row 3, and that would give us u equals 1, 3, 1, 0, 1, 3, 0, 0, 1. Okay. Then what you got to do is step 2, find L. To find L, you reverse the command. So if you have a fraction, you just take the reciprocal. If it's a positive, it turns to a negative, right? So we're going to find L. To find L, you reverse. Okay, so let me write down the command on the left. So this was your original command. There's like, where there was 1, 2, 3, 4, 5, 5. So first one was 1/2 row 1 gives us row 1. Second command was 3 row 1 plus row 2 gives us row 2. Command 3 was -4 row 1 plus row 3 gives us row 3. Three row 2 plus row 3 gives us row 3. Command 5 is 1/7 row 3 gives us row 3. So you start with the last command and then you take the invert or the reciprocal. So 1/7 row 3 will now be the reciprocal of 1/7 is 7 row 3, which gives us row 3. And then the fourth command was 3 row 2 plus row 3. So now you take the reciprocal, the negative. So instead of +3, it's -3 row 2 plus 1 row 3 gives us row 3. And then the third command was -4 row 1 plus row 3. So that's going to be a +4 row 1 plus 1 row 3 gives us your new row 3. Okay. And then 3 row 1 plus row 2, you take the negative, positive, so instead of positive 3, it's negative 3, row 1 plus row 2 gives us row 2. And then 1/2 row 1 gives us new row 1. So you take the reciprocal of that. So that's 2 row 1 gives us row 1. Okay. So what you do next is, so you're gonna move box this or kind of circle it. You start with your identity matrix and then do each row of operation or do these ones, right? Not the old command, but the new ones. Okay, so I'm gonna go ahead and box it because I'm gonna scroll down because I need more space. So what you do is start with the identity matrix. This is a 3 by 3, so it's going to be 1, 0, 0, 0, 1, 0, 0, 0, 1. If you recall, our new order of operation, our new command was 7 times row 3 gives us row 3. So you're messing with row 3 and you're going to get 0, 0, 7, 0, 1, 0, 1, 0, 0, right? Okay, keep on going. The next command was a negative 3 row 2 plus 1 row 3 gives us your new row 3. So we start with the previous and you're still messing with row 3. So it's going to give you 0, negative 3, 7, 0, 1, 0, 1, 0, 0. Okay. And keep on going. The next order of operation was 4 row 1 plus row 3 give us your new row 3. So we'll continue messing with row 3. So when you do that, that gives us 1, negative 3, 7, 0, 1, 0, 1, 0, 0. Continue. The next one is you're still messing with row 3. It's 4 times row 1 plus 1 row 3 gives us your new row 3. When you do that, that should give you 4, negative 3, 7, 0, 1, 0, 1, 0, 0. And then continue. The next one was negative 3 row 1 plus 1 row 2 gives us your new row 2. So that gives us 2, 0, 0, negative 3, 1, 0, 4, negative 3, and 7. Okay, so this is your final, and I believe that's your L, right? So now what you do is you're going to check. So check. A was 2, 6, 2, negative 3, negative 8, 0, 4, 9, 2 equals to your L, which was 2, 0, 0, negative 3, 1, 0, 4, negative 3, 7, and your U was 1, 3, 1, 0, 1, 3, 0, 0, 1. Okay. Okay. The next thing we're going to talk about is solving a system of linear equation using LU decomposition. I don't think I wrote down the directions. Yes, I did not write. So let me write this down. So the next thing we're going to do is solving a system of linear equations using LU decomposition. So here are the steps. Step 1, find U. Step 2, find L. Now, A vector x is equal to vector b is the same thing as LU times vector x gives us vector b. Step 3, define a new column matrix. Or vector y such that vector y is going to give you this matrix L augmented with vector b. And then step 4, solve U x vector x equals y, or vector x is equal to matrix U augmented vector y. Okay, so what does that mean? Let's do an example. That's another example. Let's move this to the right. Okay, so this other example is, I'm going to move it on to the right. So let's say we had vector A was 2, -3, 4, 6, -8, 9, 2, 0, 2. And we had vector B, which is 2, 2, 3. We got to solve vector A is equal to vector B. So step 1 is find your U. So this is where you make the diagonals ones and make the lower triangle zeros. So I'm going to save us time, I'm going to just put that on the computer, and when you do, you get this 1, 3, 1, 0, 1, 3, 0, 0, 1. Okay, step 2, you're going to find your L by making the upper triangle 0. So go back to vector matrix A and make these 0, these zeros, and these zeros. So when you do that, I'm going to just put that in the calculator. You get 2, 0, 0, -3, 1, 0, 4, -3. Okay, I don't think we have to worry about the commands so far. Okay, step 3. Oops. Vector y is going to be matrix L augmented with vector b. So that's going to be 2, 0, 0, -3, 1, 0, 4, -3, 7, augmented with vector v, which is 2, 2, 3. And then what you want to do is row reduce, meaning you want the diagonals to be ones and then upper and lower triangles to be all zeros. So with the help of a calculator, you're going to get this. 1, 0, 0, 0, 1, 0, 0, 0, 1, and then augmented with 1, 5, 2. So that's this is your answer. So vector y is equal to vector 1, 5, 2. Okay, so that is how you solve a system of linear equation using LU decomposition. And no, there's a fourth step. The fourth step is so find vector x by taking matrix U augmented with vector y, which we just solved. So x is equal to U is 1, 3, 1, 0, 1, 3, 0, 0, 1, augmented with 1, 5, 2. And when you do the algebra, you get, so you want to do row reduction. Basically, you make the diagonals ones and then everything else zeros. And when you do that, you get, with the help of a calculator, you get 1, 0, 0, 1, 0, 0, 0, 1, augmented with 2, -1, 2. So vector x is going to be 2, 1, -2. Okay, so that is basically how you solve a system of a linear equation using LU decomposition. Okay, let's move on. I think we have like 2 more examples. So let's do this example. It says using LU factorization, solve the linear system equation A times vector x equals vector b, where u equals 3, 0, 0, -1, 1, 0, 2, 5, 12, and L is equal to 1, -2, 3, 0, 1, 2, 0, 0, 1. And vector v is equal to 1, 3, 6. So we know that A equals L times U. What we have to do is find find U, which was given. So step 1, find U. You could put a check mark because we already found it. Step 2, find L, which we found. Step 3, take vector y is equal to vector L augmented with vector v. Step 4, find matrix X equals to matrix U augmented with vector y. Okay, so let's do step 3 and 4 because we already done step 1 and 2 because that was given. So let's do step 3 and 4. Okay, so step 3, we got to find vector y, which is equal to matrix L augmented with matrix B, which we have, right? So it's matrix L, which is 1, 0, 0, -2, 1, 0, 3, 2, 1, augmented with matrix B, which is 1, 3, 6. Then you just row reduce. Row reduced. Basically make the diagonal 0, 1s, and then upper and lower triangles zeros, right? And when you do that, that gives us and then you get, so this vector y is 1, 5, negative 7. Four is find vector x. So find vector x, it's matrix U augmented with vector y, which we just found, right? Yeah, you're right. So vector x is going to be vector U, augmented with vector y. So that's 3, negative 1, 2, 0, 1, 5, 0, 0, negative 15, augmented with vector y, which is 1, 5, negative 7. And then you row reduce, and that gives us 1, 0, 0, 0, 1, 0, 0, 0, 1, augmented with, so when you do the algebra, you get 41, 45, 8 thirds, and 7 fifteenths. So vector x is going to be this, which means your x1 is 41 over 45. Your x2 is 8 thirds. Your x3 is 7 fifteenths. Let's do one last one. So the last one says, using UL factorization, solve the linear system. And so they give us this system of equation. We have x1, x2, x3. So what do we need? We need to find u, we need to find L, we need to find vector y and vector x. So let's find A, because they don't give us matrix A. We can find it using the system of equation. So matrix A is going to be the coefficient of x1, x2, and x3. And then the equals means augmented. So matrix A would be expressed as negative 2, 3, 0, 4, negative 2, negative 4, negative 3, 1, 3, and vector B is going to be negative 1, 17, negative 9. Okay. Step 1, find U. Step 2, find L. Step 3, find vector Y by taking vector L augmented with vector B. Step 4, matrix X is equal to matrix vector U augmented with vector Y. Okay, let's do step 1. So step 1, it's negative 2, 3, 0. So what is step 1? Step 1 is find U. So it's negative 2, 3, 0, 4, negative 2, -4, -3, 1, 3. And then what we're going to do is make, what are we going to do? We're going to make the lower triangle zeros. So we kind of, yes. So we kind of have to figure out, we have to do the row of operation or the commands. And we'll just have to be a little bit careful. So the first order of operation was 3 row 1 plus 2 row 2 gives us row 2. And then the next one is 1 row 2 plus 2 row 3 gives us row 3. That's -2, 4, -3, 0, 8, -7, 0, 0, -1. So your U matrix is -2, 4, -3, 0, 8, -7, 0, 0, -1. Okay. Step 2, you're going to do L equals E inverse, E1 inverse times E2 inverse, because I think we only had, yeah, we only had two commands. It was 3 row 1 plus 2 row 2 equals row 2, and 1 row 2 plus 2 row 3 gives us row 3. So we only have two commands. So L, so write out your two identity matrix, 1, 0, 0, 0, 1, 0, 0, 0, 1. And then the other one was 1, 0, 0, 0, 1, 0, 0, 0, 1. So we had only had two. So E1 was 3 row 1 plus 2 row 2 gives us row 2. E2 was row 2 plus 2 row 3 gives us row 3. Okay, so let's start with this identity matrix, and it looks like we're going to mess with row 2. So it's 3 row 1 plus 2 row 2, so that's going to be 1, 0, 0, 3, 2, 0, 0, 0, 1. And then matrix 2 is row 1 plus 2 row 3 gives us row 3. So that's going to give us 0, 1, 2, 0, 1, 0, 1, 0, 0. And I believe if you multiply those two matrices, you're going to get L equals 1, 0, 0, -3 halves, 1 halves, 0, 0, -1 half, and 1 half. Now let's move on to step 3. We got to find matrix Y. I mean, not matrix, vector Y. So vector Y is matrix L augmented with matrix B. So we found L, right? It was 1, -3 halves, 0, 0, 1 half, -1 half, 0, 0, 1 half, augmented with -1, 17, -19, -9. Then what you want to do is row reduce, basically making all the diagonals ones and upper and lower triangle zeros. So when you row reduce with the help of a computer, you get this 1, 0, 0, 0, 0, -1, 31, 13. Step 4, find matrix X is going to equal to this -2. So matrix X is what? Matrix U augmented with matrix Y. -2, 4, -3, 0, 8, -7, 0, 0, -1, augmented with -1, 31, 15. And then what you do is row reduce. And you get this. This is your answer. So that means x1 is 5, x2 is -15/2, and x3 is -13. Okay, so that wraps it up for this video lecture. I'm going to stop here.